Good evening, dear students. So in the last class, we have done D and F block elements, right?
Yes, ma'am.
Okay. Yes. So today we are going to see the next chapter, that is alcohol, phenols, and ethers. Okay. So alcohol, phenols, and ethers. So how do you represent alcohols?
Benzene.
Yes, R
R.
ROH, right? Alcohols. So alcohol, phenols, ethers. So these are all what? These are all organic compounds, right? So they have functional group. So this is the functional group, okay, where R is your what? It should be a aliphatic. Okay, it will be a aliphatic. It will be a alkyl group. Aliphatic in the sense it will be a alkyl group, right? That is your CH3, okay, ethyl, CH3, CH2, right? So like this, propyl, okay. So these, so in your alcohols, R will be a aliphatic group. Okay, so that is a alkyl group. That is CH3, ethyl, methyl, propyl, butyl, etc. And for phenols, okay, how do you represent phenols? ROH, okay, where R will be your aromatic ring, right? It will be your aromatic ring. So suppose if I have a benzene, okay, this is a benzene. So benzene connected to OH. So this is what? This is a phenol,
No.
right? Same way for aliphatic, if I gave CH3, okay, if I take a alkyl group R as CH3, OH, this is methanol. Okay, this is methanol. So this is a alcohol. It comes under alcohol. Then ethers. Okay, ethers. How do you represent ether? R O R dash. Right. So these R and R dash. Okay, it can be a alkyl group or a aryl group. It can be a, yes, it can be both. It can be a alkyl group or as well as aryl. So it will have a O linkage. Okay, it will have a O linkage. RO R dash. Suppose if I take R as CH3, okay, and R dash as C2H5, suppose. So what will be the name? So now this is methyl, this is ethyl, right? So this will, first you have to follow the alphabetical order. So first will be a ethyl. So ethyl, methyl, ether, right? Again, suppose if it is CH3, OCH3, then yes, it will be dimethyl ether. Okay, so like this. So alcohol, phenols, and ethers. Okay, so just I have told you the functional groups. Okay, how they are represented. Okay, fine. So I hope you have gone through the synopsis, right? All the important this notes on this particular chapter: alcohol, phenols, and ethers. Okay, so based on this, let us solve the questions. Okay, so this is the first question. Anisole can be prepared by the action of methyl iodide on sodium phenate. The reaction is called as. Okay, so anisole. How do you represent anisole, students? How do you represent anisole? Anybody? How do you represent anisole? How anisole? Anisole is what? Benzene ring. Okay, benzene with OCH3. Okay, with OCH3. So this is called as anisole. Okay, methoxybenzene. Methoxybenzene. Okay, so this is a anisole. So how can you prepare anisole? So it can be prepared, they are saying, by action of methyl iodide. Methyl iodide is what? CH3I. Okay, on sodium phenate. Now what is sodium phenate? Your phenol. Okay, when it is reacted with sodium hydroxide, okay, when it is reacted with sodium hydroxide, you get what? Your, okay, so this is Na plus OH minus, right? So this will split into Na plus OH minus. So this is O minus H plus. So H will be cleaved and your O minus and Na plus. So like this. So this is your plus H2O. Okay. So like this. So this is the sodium phenate. This is called as sodium phenate, or it is also called as sodium phenoxide. Okay, sodium phenoxide. Okay, so what we are doing? Methyl iodide is reacted with your sodium phenate. Okay, NO minus Na plus. Okay, so this reaction, what is this name reaction called as? They have asked. So options are A, Fittig reaction, B, Itard reaction, C, Woods reaction, and D, Williamson reaction. Fittig reaction. What is Fittig reaction? In Fittig reaction, okay, we have what? Two aryl, this is there, okay, two aryl halides. Two aryl halides. In Fittig reaction, we take two aryl halides. Suppose I take chlorobenzene. Okay, 2-chlorobenzene. It reacted with Na. Okay, in the presence of what? So again, one chlorobenzene in the presence of dry ether. Okay, in the presence of dry ether. So what will be the product? What will happen? So this, okay, this will be a byproduct, that is 2NaCl. And what will be the main product? It will be diphenyl, right? Yes, diphenyl or biphenyl. So this is a Fittig reaction. Can you see such any reaction here? Is any two aromatic ring fused? No, right? We are not using any dry ether also. So it is not a Fittig reaction. Then what is Itard reaction, students? What do you do? Okay, again, similarly, we'll see Woods reaction only. It will be easier. So in Woods reaction, what we are doing? In Woods reaction, we have aryl halides, right? Suppose I'll take CH3. Sorry, I have alkyl halides. Okay, in Woods reaction, same. It will be alkyl halides. Both will be alkyl halides. Okay, my byproduct will be same. What will be my main product? It will be ethane, right? So this is the above reaction as your Woods reaction? No. Okay, so in Woods reaction, we are taking alkyl halides. Okay, alkyl halides reacts in the presence of sodium and dry ether to give you a higher alkane. In Fittig reaction, aryl halides will react. Okay, now what is Itard reactions?
Toluene reacting with chromium chloride in presence of pH2.
Yes, yes, very good. Okay, suppose if I take what? Let me clear this. So suppose everything I cleared. What all I want, okay, this I'll clear. So here, suppose if I take your this is CH3. What is this name? What is the name?
Toluene.
Toluene. Very good. So if I take toluene and if I react it with chromyl fluoride, okay, chromyl fluoride, what I'm going to get? I am going to get, so directly I'm going to write, I'm going to get a benzaldehyde. Okay, I'm going to get a aldehyde. I'm going to get a aldehyde here. So I have not written the intermediates. Okay, directly I've gone through the main product. So here, is there any aldehyde formation? No. So this is also wrong. Williamson ether synthesis. Okay, Williamson ether synthesis. In that Williamson ether synthesis, okay, what is the reaction? One alkyl halide will be there. Okay, one alkyl halide will be there. Okay, and alkyl halide will react with what? It will react with the, so here you can see in the product, what you can see here. First you see the product. Okay, one is a aryl group, another is a ether, this what? Alkyl group. Can you see as RO R dash? Yes, so this is a ether, right? Ether. So in ether, okay, so what we are doing here, we are synthesizing the ether. Okay, we are forming the ether. So this is a ether synthesis. This is a Williamson ether synthesis. So what we are doing, one will be a you are taking a sodium or potassium this, okay, salt, and what is happening here, so you are going to get plus NaI. Okay, plus NaI will be the byproduct, and your CH3 will get attached to this phenoxide. Okay, that is your phenoxide ion. okay, to the phenoxide ion. So this is a Williamson ether synthesis. You are preparing your Williamson, you are preparing your ether. So what is Williamson ether synthesis? One will be a alcohol, sorry, oh, it is a salt of, it is like a sodium salt, right? So you are taking a sodium salt, or you are going to take a, that I can take a sodium alkoxide, or I can take a potassium, this, okay, potassium alkoxide, or you can take a arene compound. Now here they had taken what? They have taken a benzene ring, right? Plus you are taking a alkyl halide. Okay, plus alkyl halide. So this you are going to get a RO R dash. So you are going to get a ether. So our answer is option number D, Williamson ether synthesis. Okay, let us go for the next one. Catalytic dehydrogenation, catalytic dehydrogenation of a primary alcohol gives, so when you do a catalytic hydrogenation, okay, when you are doing catalytic hydrogenation, so what catalytic hydrogenation means? What? In the presence of, so I am going to take a primary alcohol. So let me take a primary alcohol. So this is a primary alcohol. So to this primary alcohol, I am going to do catalytic hydrogenation. So I am going to use copper. Okay, I'm going to use copper at 300 degrees Celsius. Okay, at 300 degrees Celsius. So what I'm going to get? I'm going to get, so when you do hydrogenation, what do you mean by dehydrogenation? What do you mean by dehydrogenation? Removal of D. D means removal. Okay, removal. And hydrogen. Okay, so removal of hydrogen. So we are removing hydrogen from our final product. Okay, so when you remove from your this, okay, if I remove this aldehyde, hydrogen, okay, if I remove this hydrogen, or if I remove here CH2, okay, so if I remove one hydrogen from here, one hydrogen from here, and one hydrogen from here, what I'm going to get? RCHO. Okay, I'm going to get what? I'm going to get a aldehyde. Okay, I am removing hydrogen molecule. So what is the answer? Option number D. Okay, so catalytic dehydrogenation of a primary alcohol, it gives you what? It gives you a aldehyde. Is it clear? Okay. Next question. Among the following, which is least acidic? Among the following, which is least acidic? So options are A, paranitrophenol, B, parachlorophenol, C, phenol, and D is orthocresol. Okay, it is orthocresol. O, orthocresol. So among the following, which is least acidic? A, paranitrophenol, B, parachlorophenol, C, phenol, and D, orthocresol. So now, if I write the structures, okay, let me write the structures first. So this is with respect to phenol, this is at para position. So this is paranitrophenol. Next is phenol, and at para position you have chlorine. So this is parachlorophenol. Then is you having phenol. Okay, next you have orthocresol. Orthocresol means what? With respect to your phenol, you add ortho position, you have a methyl group. So this is a orthocresol. So they have asked which is least acidic. Okay. Now, what are these? Now, everything is, but the parent chain is phenol, right? Everywhere. But what you can see here, nitro group, chloro group, and one methyl group. So what are these? What are the role of these substituents? Nitro and your chlorine. Okay. So what they come under what? Nitro and chlorine. They come under what? Nitro and chlorine. They are the electron withdrawing group, right? We term them as electron withdrawing groups, right? We term them as electron withdrawing groups. So what they will do? They will withdraw the electron towards itself, right? They will withdraw the electron towards itself from the benzene ring. the electrons are withdrawn towards itself. So what will happen? What will happen if the electron withdrawing group are withdrawing the electron towards itself? What will happen to the electron density of the benzene ring? Yes, it will decrease, right? So electron withdrawing group, what they will do? They will decrease the electron density in the ring, okay? Because they are withdrawing, right? They are taking the electron towards itself. So what is happening to the electron density in the ring? It is decreasing. So electron density decreases, okay, due to presence of electron withdrawing groups, okay, in nitro and chlorine. Okay, now methyl group. Now, when you see this methyl group, what is a methyl group? Methyl group is a electron donating group. Okay, it will give electrons. It will give electrons to the benzene ring. So what will happen? What will happen to the electron density of the benzene ring? Electron density will increase. Okay, remember that whenever you have electron withdrawing groups, they will decrease the electron density. And whenever you have electron donating group, they will increase the electron density of the benzene ring. Okay, so thus what will happen? Now here, okay, when you are having the electron withdrawing group, as they are decreasing the electron density, what will happen to the acidic character? It will increase. Okay, the acidic character will increase. So remember this, acidic character increases. Okay, it will increase. Acidic character will increase. Now here, when you have electron donating group, what will happen to the electron density? Electron density will increase and acidic character will decrease. Okay, remember this, acidic character will decrease. Now, arrange now with this information. Can you arrange the molecules now? So, which will, they have asked which is least acidic. So, which is least acidic? Your
Option D.
yes. Okay, your para orthotresol, right? Because it is having the electron with donating group. So because of electron donating group, the electron density will increase, but the acidic character will decrease. So it is, so this is the least, then will be a phenol, then will be your chloro, and this is the most acidic. Okay, this is the most acidic, this is the least acidic. So remember this. So electron withdrawing group increases the electron density, and what will happen to the decreases the electron density, and what will happen to the acidic character? It will increase. And whenever you have electron donating group, what will happen? Electron density will increase and acidic character will decrease. Okay, so mention this. And among nitro and chlorine, nitro is the most what you can say, the electron withdrawing group. Okay, it is a powerful electron withdrawing group between the chlorine and this. It is the most, okay, it is the most acidic because of the presence of nitro group. It is the most acidic, and because of the this what is that? Your methyl group, as it is a electron donating group, so it is least acidic in nature. So option number D is the answer. Okay. The best method for the conversion of an alcohol into an alkyl chloride is by treating the alcohol with. So if I want to get what? A conversion of alcohol into alkyl chloride. So what we are doing here? I want a alkyl chloride. So from alcohol. So what we are doing? Alcohol, when you react it with. So there are four options. A, PCl5, B, thionyl chloride in the presence of pyridine, C, dry HCl in the presence of anhydrous zinc chloride, and D, phosphorus trichloride. Okay. Now, when you have alcohol, so when you study the methods of preparation of alcohol, so there, this is the best method. Okay, very best method. This is mostly used. Why? Because alcohol. Okay, when you react it with thionyl chloride, so thionyl chloride in the presence of pyridine. So pyridine is a base. Okay, pyridine is a base. What you are going to do? You are going to reflux this. Okay, you are going to reflux this reaction what I am going to get? I am going to get a alkyl chloride. Okay, plus the byproducts obtained here are gases. Okay, so easily these gases will escape out, right? These gases will liberate. Okay, they will be escaped out. So the product formed will be what? It can be more. Okay, the product yield will be more here. So the yield is more. So because of that, this is the best method for conversion of alkyl into alcohol into alkyl chloride. Why? Because the byproducts obtained, they are what? They are gases. Okay, they are gases and they will easily escape out in the what? In the atmosphere. Gases, they will not remain in the container, right? So after reaction, whatever the product has to be formed, the product will be formed and remaining will escape out. So there is no any impurities or no any byproducts. Okay, again, where you can see that the yield will be less. So the alkyl chloride formed by this method will be more. Okay, the byproduct of the product obtained will be more. Okay, so this is the answer. So thionyl chloride. Why? What is the reason? Main reason? Because the byproducts are gases and they will easily escape out. Okay, in the atmosphere. From the mixture, they will easily get escaped out in the atmosphere. So this is the reason. Okay. Lucas test is associated with. So Lucas, okay. So there is a main important this, okay. When you are studying for board exams also, remember to study about Lucas reagent. Okay, Lucas reagent, very important. They will ask you a question. Differentiate, okay, differentiate using Lucas reagent between primary, secondary, and tertiary. Or you can, or the question will be, how will you differentiate primary, secondary, and tertiary alcohols using Lucas reagent? Okay, so this is a very important question, 3 marks question. Okay, how can you differentiate primary, secondary, and tertiary alcohols using Lucas reagent? So Lucas reagent, what is the Lucas reagent? It is concentrated HCl, very important. Please, you can make a note. Okay, it can be asked in MCQs or in the form of fill in the blanks also. Like what is Lucas reagent? Concentrated HCl and anhydrous ZnCl2. Anhydrous ZnCl2. Concentrated HCl and anhydrous ZnCl2 is your Lucas reagent. Concentrated hydrochloric acid and anhydrous. Anhydrous means water molecule. Okay, water molecule associated with zinc chloride is removed. So there is no water molecule. Anhydrous means there is no water, moisture present. So concentrated HCl and anhydrous ZnCl2 is the Lucas reagent. Now, so just now I said you Lucas reagent, why it is used? For differentiating the alcohols, okay, between the primary, secondary, and tertiary. And how you are going to differentiate it? When you react your Lucas reagent, okay, when you react your Lucas reagent with primary alcohol, it will give you no PPT. You know what is PPT? What is PPT? PPT means what? Insoluble mass. Okay, insoluble mass. Now, when you react, okay, when you react in the test tube, okay, one reaction, one mixture, this is there. To that, you are adding one more solution. So this may turn like this white color. Okay, this may turn white color, or I'll show you yellow color. Okay, because white cannot be shown. So it will be like curd form, in the form of curd. Okay, curd, you know curd. So in that form it will be. So suppose if it is in yellow, like yellow curd, okay, white curd, orange curd, like that. So that thickness it will be. So that is called as PPT. So when you react your Lucas reagent with primary alcohol, if there is no PPT, okay, solution is different, PPT is different. Solution means what? Suppose what I have done, Lucas reagent. Okay, I have primary alcohol here. Okay, to that I have added Lucas reagent. Now it has turned like fruity. How the juice will be? Okay, like a solution. Okay, it is like a solution. So that is different. Okay, and like curd formation is different. Curd will be thick, right? that is PPT. And if the solution is turned like yellow solution, okay, that solution is different. So solution is different, PPT is different. PPT will be like curdy form, okay, like curdy form. And solution will be like, suppose if I am telling yellow, you can take like fruity, fruity, or maybe your yellow color, any solution, okay, like transparent, you can see, okay. So that is not curdy form. So so when I react my Lucas reagent with primary alcohol, it will give you no PPT. It will give you no PPT. Now, so this is the first differentiation. Then suppose now what I have done, I have taken again Lucas reagent. Okay, I have reacted with secondary alcohol. Okay, secondary alcohol. So what will happen with secondary alcohol? It will give you PPT. Okay, it will give you PPT after 5 minutes. Okay, after 5 minutes. So after 5 minutes, you are going to get PPT. Okay, like curdy form. Then, and so this is for primary, this is for secondary, now tertiary. Tertiary, Lucas reagent reacts with tertiary alcohol. What you are going to get? Immediate. Okay, immediately you are going to get the PPT. So this is the differentiation. Okay, so primary alcohol, it will give you no PPT. Secondary alcohol, when you react with Lucas reagent, you are going to get PPT after 5 minutes. And tertiary alcohol, when you react with Lucas reagent, you are going to get immediate PPT. So this is the differentiation. Okay, so when the alcohol, now if they ask you how, if the alcohol is reacted with tertiary alcohol, what you are going to get? You are going to get the PPT immediately. Okay, fast, right? When you react your alcohol with a Lucas reagent, that is your primary alcohol, what will be the result? You will say no PPT. If the alcohol, if your secondary alcohol has reacted with Lucas reagent, what you are going to say? I'm going to get PPT, but after 5 minutes. Okay, so this is the differentiation. So like this, very important question asked for theory also. Okay, in your board exam also. So where it is used, Lucas reagent for differentiating the alcohol, primary, secondary, and tertiary alcohol. Okay, let us go for the next one. Okay, so here is a question. 1 mole of an organic compound A with the formula C3H8O reacts with 2 moles of HI to form X and Y. When Y is boiled with aqueous alkali, it forms Z. Z answers the iodoform test. The compound A is. Okay. So what all they have asked? A is there. Okay. It is reacting with what? It is reacting with 2 moles of HI. Okay. It is reacting with 2 moles of HI and it is forming X and Y. Okay. It is forming X and Y. This Y is what? It is boiled. Okay. It is boiled with what? With alkali. Okay, it is boiled with aqueous alkali. Can I take KOH or NaOH? Okay, this is alkali. I can take KOH or NaOH. So I have taken here aqueous KOH or NaOH. So what I'm going to get? I'm going to get Z. So this Z is answering the iodoform test. Okay, it is answering the iodoform test. What is the compound A? They have asked what is the compound A. So first tell me what is iodoform test. Who answers the iodoform test? Who will answer which compounds, which functional group will answer the iodoform test? Any idea? So iodoform test, okay, it is used for the presence of carbonyl compound. So it is used for the presence, it shows the presence of carbonyl compound. What are carbonyl compound? Okay, your ketone, your aldehyde, right? Your carboxylic acid, right? So these are the carbonyl compound. So then this what it can be this can be answered. Okay, iodoform test is best for your aldehydes, ketones, and alcohols also. Okay, for your alcohols also. So how it is, what is the reaction? Okay. So let me clear here. So how this the iodoform test is there? I'll show you. Iodoform test. Okay, iodoform. So iodoform test. Okay. So you one will be your methyl ketone. Okay, one will be your methyl ketone. So this is a methyl ketone. So methyl ketone, what it will do? It will react with sodium hypoiodide. Okay, what is sodium hypoiodide? NaOI. Okay, NaOI. So how you are going to get the sodium hypoiodide? When you react your NaOH with iodine. Okay, when you react with NaOH with iodine, you are going to get what? Sodium hypoiodide. Okay, this the name is sodium hypoiodide. Okay, this NaOI. So your methyl ketone, when it reacts with sodium hypoiodide, okay, what you are going to get? What is the product? The product obtained is a iodoform. Okay, you are going to get a iodoform. So CH3I, CH3I, CHI3, CHI3. So this is the iodoform. So this iodoform, okay, how it will be? This will be a yellow color, bright yellow color, okay, bright yellow color, bright yellow PPT, okay, PPT, it will be bright yellow color PPT. So how you are going to get iodoform test? When methyl ketone, when it reacts with sodium hypoiodide, iodoform is formed. Iodoform is what? CHI3. Okay, so this will be what? This Z will be a carbonyl compound, either a aldehyde, either a ketone or a alcohol. Okay, now let us find out now. Okay, let us find out then. So so this is iodoform test. Okay, now what is A? CH3I. Let me clear this. Okay. So CH3, C3H8O. Okay. So with HI, can I take here one ether? Okay. Because see here, if I take a ether, if I take a ether here, if it is CH3, okay, so this will be CH3. Okay, one oxygen is O is there, oxygen, and again one is C2H5, 5, 6, 7, 8, right? So it is a ethyl methyl ketone, ether. Okay, ethyl methyl ether, ethyl methyl ether. So this is your CH3O. Okay, this is your CH3O. If it reacts with your 2HI, okay, let me write it here. So if this is CH3O C2H5, what will be my product? X and Y. So what will be the product? What will be my product? One will be a CH3I. Okay, another will be, because two moles are there. One mole will react with this, another mole will react with this. So you are going to get ethyl iodide and methyl iodide plus water. Okay. So again, this Y. Now what is Y? This is X. This is Y. So if I take Y as your ethyl iodide, C2H5I, and I boiled with aqueous KOH or NaOH, what I'm going to get? I'm going to get what will be that? So your iodine, okay, your iodide, I will be replaced by OH. I'm going to get ethyl alcohol. Okay, and alcohols will give positive test for iodoform test. So our answer is So ethyl methyl ether, ethyl methyl ether, or it is a methoxyethane, right? Option number D. Option number D. Understood?
Yes, ma'am.
Yes. Okay. So like this. Okay. So like this, you need to know what is iodoform test, which it will give. So you have to just recall all the tests. Next question. And oxygen containing organic compound upon oxidation forms a carboxylic acid as the only organic product with its molecular mass higher by 14 units. The organic compound is, so an organic compound is there, okay, and oxygen containing organic compound. So it is undergoing oxidation and it forms a carboxylic acid. Okay, this is carboxylic acid as only the product. Okay, and the molecular mass has increased by 14 units. So they have asked which is this organic compound. Okay, which is this organic compound. So the difference between the previous and this is 14 units. Okay, so if I take this, so this is what is the unit, calculate the mass of this carbon is 12 plus oxygen is 16 plus 16 plus 1. So how much it will be? 45. Okay, so 45. Now here, so the unit difference is only 14 units. So, and it is undergoing oxidation. So if I do oxidation on alcohols, okay, we know that when we take primary alcohols, when you do oxidation, you are going to get what? Alcohols. Now, suppose if I have here R and ROH, okay, so I'm going to add what? Oxygen. So oxygen, so again one oxygen is added here. So what I'm going to get? R, uh, RC double bond OH. Okay, so suppose if I take like this, CH3, CH2, OH. Okay, let me do oxidation of this. Calculate. So this will be CH3. Okay, oxidation means what? Removal of hydrogen and addition of oxygen. So it will be COOH. So it will be what? Now just see, calculate the mass now. Let us see mass. Carbon is 12, 12 plus 12 plus 16 plus 3, 4, 5, 6. Calculate this, and carbon 12 plus 12 plus 4 plus 16 plus 16. Calculate now. Both of this is
46, ma'am.
46. Okay. And this 6 is 12, 2, 3, 4, 5, 6, 60. Okay. 60 minus 46, 14. Right. So the mass is higher by 14 units. So an oxygen containing organic compound. So this is an oxygen containing organic compound, that is a alcohol. So answer is primary alcohol. So primary alcohol, when you do oxidation, you are going to get what? Organic compound, that is a carboxylic acid, which is having higher mass of 14 units. So when you see the masses, okay, it is increased by 14 units. Okay. So answer number B. B is the answer. Okay. Phenol. Phenol. In the presence of X, okay, forms a tribromo derivative. Tribromo derivative. They have asked what is this X? What is this X? Tribromo derivative means what? Tribromo derivative means like this. Phenol. Tribromo means like this. Okay, so what is this? Phenol is like this. So what will be answer? Bromine in benzene, bromine in water, potassium bromide solution, bromine in carbon tetrachloride at 0 degrees Celsius. So phenol, when you react it with bromine water, okay, bromine water, you are going to get tribromo bromine, okay, phenol. So that is 2, 4, 6. tribromo-phenol. So this is the answer. So our option is option number B. So phenol, when you react it with bromine water, okay, you are going to get a tribromo derivatives. That is 2, 3 is here. 1, 2, 3, 4, 5, 6. So 2, 4, 6, 1, 2, 3. So tri, bromo, and phenol. Okay, so like this is the naming. So phenol, when you react it with bromine water, you're going to get a tribromo derivative. So option number B is the answer. Okay. So this is a reaction given. Okay, you have a ethene. Ethene is there. When you react it with concentrated H2SO4. What is concentrated H2SO4? What it is called as? It is called as a dehydrating agent. Okay, dehydrating agent means what? It removes the water molecule. Right. Now here you have a double bond. Okay, now here you have a double bond. So ethene, when you react it with this concentrated H2SO4, it is going to add. Okay, it is undergoing a addition reaction with the concentrated H2SO4. Concentrated H2SO4 is also called as a dehydrating agent. Dehydrating agent. Okay, remember that. Dehydrating means it helps to remove the water molecule. Now concentrated HCl here, it is acting as, or it is used to do the addition reaction. So what will happen now when you undergo addition reactions here? CH2 double bond CH2. Okay, so one of the bond will be broken here. Okay, and what will happen? Concentrated H2SO4. Right, when concentrated H2SO4 will split into H plus and HSO4 minus. Right, you know that when H2SO4 will split as H plus and H2SO4 minus. So at one carbon in any both this ethene is a symmetrical molecule, right? Across the double bond, the number of carbon atom is same. So when it is undergoing addition reaction, so anywhere one hydrogen is added, anywhere HSO4 is added. So what I'll do, I'm going to add hydrogen here. So it will be what? CH3, and here I'm going to get HSO4. So it will be what? CH2HSO4. Okay, so I am going to write the A as what? CH3 CH2HSO4. Okay, so this is our A. This is our A. Now A, what we are doing? We are going to heat it. Okay, we are going to heat it with water. Okay, after heating with water, what I am going to get? Let us see. Just a second. Okay, so here now CH3, CH2, HSO4. I hope you have got it. Okay, CH2 double bond CH2. This is a symmetrical alkene. What do you mean by symmetrical alkene? Across the double bond, the number of carbon atom is same, right? Across the so what will happen when you are doing addition reaction? When you are doing addition reaction, so H2SO4 will split into H plus and HSO4 minus, right? So at when you are breaking the bond, okay, CH2, one bond will be broken, your one hydrogen will be added, and your HSO4 will be added. So like this. So this I have written like this. Now, what I have done to this, I am going to add water. Okay, I'm going to add water. I'm going to heat it with water. So what will happen when you heat it with water here? Yes. So again, water H plus and OH minus. Okay. Now here, which is the negative part in the above reaction? This is your negative part. So what will happen? You are going to get CH3, CH2, OH. So your HHO4 will be replaced by your OH. So this is also the negative part, right? Which was added. So that will be replaced by OH. So I am B will be CH3, CH2, OH. Now, further, I am going to react it with PBr3. PBr3. Okay. Now here, what is the negative part? Here, this is the negative part. Here, in between PBr3, Br is the negative part. So what will happen? OH will be replaced by your B. So Br. So what I'm going to get? CH3, CH2, Br. Right. Now, CH3, CH2, Br has converted into ethene. How I can convert it into ethene? By doing, yes, let me clear this. Okay. So this was CH3, CH2, HSO4. This is CH3, CH2, OH, and this is CH3, CH2, Br. Now here, what I am showing you, CH3, CH2, Br, okay, to ethene. Okay, how, what is happening here? What is happening here? I'll show you. So C, I'll show down. Okay, C, H, 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 C, H, H, Br. So what is happening? Double bond formation is formed here. Let me write this also. Okay. C, H, H, double bond C, H, and H. Right. Or I can write like this, little twisted. H, 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 and H. Okay, so this is our ethene. This is your. Now what is happening here? It is undergoing a dehydrogenation. Okay, it is called as dehydrohalogenation. Okay, if this bond, what will happen? This bond will break and it will form a double bond. So what is forming here? Okay, this will go, okay, and it will form what? It is forming a double bond and this will leave. Got it? Understood or no? What is happening here? So what is happening? I'll show you again. H, take another pen. Okay, H, this was your H and Br. Okay, so what is happening? This is forming a bond and this is leaving. So one hydrogen and one halogen is leaving. So what it is? It is a dehydrohalogenating, which is a dehydrohalogenating agent. Forgot? Which is a dehydrohalogenating agent. Remember. Alcohol, not alcohol, this haloalkanes and haloarenes. Dehydrohalogenating agent. Alcoholic KOH. Forgot?
Yes.
Okay, so alcoholic KOH is the dehydrohalogenating agent. So which is our D? D is the alcoholic KOH. So when you use alcoholic KOH, what it is going to do? It is going to remove dehydro. Hydro means hydrogen and halogen means halogen. So it is going to remove one hydrogen and one halogen. So what is happening here? What is happening here? What is happening here? So just see here. So this is forming and this is going out. So this will form a bond here. Okay, this will form a bond here and this will leave. So is it? This is same, right? So this is the reaction. Okay, so which is our answer? Now they have asked identify B and D. What is our B? B is our alcohol, that is ethanol, right? B is our ethanol and D is our alcoholic KOH. So ethanol and alcoholic KOH. Option number D. Option number D. Okay. Is it clear?
Yes, ma'am.
Okay. So like this, you should not forget the roles of the agents. Okay. What is alcoholic KOH? Very important. Alcoholic KOH is a dehydrohalogenating agent. Okay. D means removal. Okay. Removal of hydrogen. Okay. And one halogen. I can take HX. Removal of hydrogen. X can be your Cl, Br, iodine, etc. Like, very important. Okay. Okay. Now, this you have to answer. The compound which gives turbidity immediately. Turbidity is nothing but PPT. Immediately with Lucas reagent at room temperature is. Which will give fast reaction with Lucas reagent? Which alcohol? Tertiary. Yes. Now, they have given you 4 different compounds. Okay. One is butane, 1-ol, then is butane, 2-ol. Now here, what is the, okay, tertiary, but you need to know now the structures. They have given the name of the compounds. So you have to know the structures, and with the help of structures, then you have to tell me. One more is 2-methyl propane 1-ol. Okay, now tell me. First write the structures of these and tell which is a tertiary among this. And that will be your answer. First is butane 1-ol, butane 2-ol, tertiary. Third one is 2-methyl propane 2-ol, and fourth is 2-methyl propane 1-ol. Butane. Butane means 1, 2, 3, 4. Okay. Then at one position you have OH. Right. At one position you have what? OH. So butane, if I take CH2, 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 wait, CH3, CH2, 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 OH. Okay, so one.
Ma'am, is it option C?
Option C. Okay, so this is butane. Okay, butane 1-ol. Right, butane 1-ol. So this is a primary. Then butane 2-ol. So 1, 2, 3. So at second position you have your alcohol. So CH3, CH2, CH. So 1, 2, 3, and 4. This is a what carbon is attached to other two carbon atoms. So this is a secondary. So this is also wrong. Then 2-methyl propane 2-ol. 2-methyl propane. Propane means 1, 2, 3. Okay, at two position you have methyl. At two position you have your OH. So CH3, CH3, 2-methyl. Okay, propane 2-ol. So 1, 2, 3. So carbon attached to 1, 2, and 3. Yes, so this is a tertiary. Very good. Okay, so this is a tertiary. So option number C is the answer. Yes, option number C is the answer. Okay. Okay. One more question. Power alcohol is a mixture of. So just remember what is a power alcohol. Power alcohol is 80% petrol, 20% ethanol, small quantity of benzene. Okay, B option. A mixture of 20% ethanol, 80% gasoline. That is your petrol. Gasoline is nothing but your petrol. Okay, is called as the power petrol alcohol. Where it is used, power alcohol, to drive for the engines to drive power. Okay, in the what you call racing bikes, racing car. Okay, there you use this power alcohol. Okay, so that it is used in the internal combustion of these engines to drive power, so that they can build the power. So power alcohol is 80%, 20% ethanol, 80% petrol, gasoline. Option number B. Okay, last one question will do. Identify C in the following. Okay, you have to follow, identify the C in the following. So benzene is there, is reacted with CH3, CH, CH3Cl. Okay, in the presence of anhydrous aluminum chloride and HCl. We are going to get A. This A is reacted with oxygen in the presence of 130 degrees Celsius to give you B. This B is reacted in the presence of dilute H2SO4 at 100 degrees Celsius to give you phenol plus C. They have asked to find out what is the C. Okay, what is the C? So let us follow the reaction. So this is the what you call very important name reaction, that is the cumene synthesis. Preparation of phenol by cumene synthesis, very important. Okay, name reaction. Preparation of phenol by cumene, from cumene, very important for board exams. Okay, so this is your benzene. Okay, this is your isopropyl chloride. This is your isopropyl chloride. Isopropyl chloride. Then what will happen now? Isopropyl chloride. So this will attack here. Okay, and you are going to get what? benzene, CH, CH3 and CH3. Okay. And what I'm going to get? I'm going to get a isopropyl benzene. I'm going to get a isopropyl benzene. It is called as cumene. Okay, cumene. Now this is our A. This is our A. Now this A is reacted with oxygen. Okay, at 130 degrees Celsius. So what I'm going to get now here? Okay, there will be introduction of oxygen here. Okay, O2 molecule, O2 linkage. So what will happen here? See here, oxygen. Okay, C, CH3. Okay, then I clear this. Here CH3 and OOH. So here what is happening? Your O2 linkage will be added. So what is the name of this compound now? This is called as cumene.
Hydroperoxide.
Very good. Okay, so whenever you have a OO linkage, it is called as hydroperoxide linkage, right? So this is a cumene hydroperoxide. So this is a cumene hydroperoxide. So this is our B. This is our B. Now this B further is reacted with dilute H2SO4 at 100 degrees Celsius. What I am going to get? What I am going to get? I am going to get a phenol. Okay, I'm going to get a phenol. I'm going to get a phenol plus here plus acetone CH3 C double bond O CH3. So when you are writing the manufacture that is your preparation of phenol from cumene, okay, what all is important step? This is important step. This is important step and byproduct is important. Okay, you should not only write phenol. Okay, you should write this also. And in organic chemistry, whenever you are writing the reaction, you should write the names also. Okay, very important. If you know the names, write the names also. Okay, so that the examiner will be more convinced. Okay, he'll be happy by seeing your structures. Okay, with the names. So okay, so this so whenever you are writing the reactions, please write the names also. So benzene reacted with isopropyl chloride. Okay, you are going to get isopropyl benzene, that is cumene. Okay, that is our A. Then reacted with O2 in the presence of 130 degrees Celsius to give you cumene hydroperoxide. Okay, B. This, when you do dilute with the help of dilute H2SO4, you are going to get what? A phenol. And C, byproduct. Here the byproduct is very important. So from this you can prepare acetone also. Understood?
Yes, ma'am.
So what is the answer? This your acetone is also called as the propanol, right? Propanol. So option number C, propanol. Propane, because this is propane. So 1, 2, and 3. So propane, non, ONE for ketone. So propane. Okay, so option number C, propanol. Is it clear? Okay. Here again one question. I think you can tell this. Which of the following is strongly acidic? Phenol, orthopresol, paranitrophenol, or paracresol? Tell me.
Paranitrophenol.
Yes. Why? Paranitrophenol is the electron withdrawing group. What will happen to the electron density? Electron density will be decreased. And what will happen to acidic strength? Acidic strength will be more. Right? So paranitrophenol. Yes. Option number C. Okay. Fine. So these were some of the questions. Okay. Uh, so try to solve many questions. Okay. If you have any questions with you, you can solve more question on this particular topic. Okay. Any doubts? Okay. Fine. So, okay. Fine. Then I'll end this session here. Okay. So we'll meet in the next class. Okay. Thank you. Bye.
Bye.